Okay, so we're going to start chapter 3, and it's going to be over polynomial functions. And first we're going to just talk about their graphing characteristics. So a polynomial is just any type of a function that has a degree in it. So variables to a certain degree. The general name is a polynomial. Quadratic is a type of polynomial. So standard form of a polynomial is when all like terms are combined, so no multiple x squares, multiple x's, anything like that. All like terms are combined, and then they're listing in order from biggest degree to smallest degree. That's called descending order. So when we did quadratics, it was x squared, and then the x, and then the constant. That remains true for every type of polynomial function. The leading term is the term that has the biggest degree in the polynomial. So the degree, again, is that little number in the corner, the exponent. Whichever one is the biggest, that one goes first, and that is your leading term. So in this example, my x to the fourth would be my leading term. The degree is 4. And then the number in front, the 6, is the coefficient. And this is in standard form. It goes from biggest degree, which is the fourth, and then the squared, and then the linear, and then the 1 is a constant. So it goes in descending order. We can determine a lot from that leading term. You can tell what's going to happen on the ends of the graphs. You can tell how many possible zeros you would have, and you can also tell how many times that graph might turn around. Like a quadratic, for example, our quadratic was U-shaped. It only turned around once. It went down and then it went up. That's because its degree was 2. It also only could have at most 2 answers. We could have 2 answers, 1 answer, or no real answers. That's how we got imaginary answers. Again, because that degree was 2. Also, I know that both ends go the same direction because the degree was 2. So, the degree of a polynomial determines the max number of zeros, the max number of turning points, and the end behavior. The max number of turning points is 1 less than the degree. So my x squared, again, was a quadratic. It turned around 1 time, down, and then up 1 turn. It could have at most 2 zeros. So the number of zeros is equal to the degree. And then again, the end behavior is also determined by that x squared. So end behavior is based off of what that exponent is, if it's even or odd. If we have an even degree polynomial, so for example, x squared, my ends are going to go in the same direction. Either both up or both down. So that is determined, the up or down, by the sign in front of that exponent. So is that a positive number or is it a negative number? If you have a positive coefficient, so for example, we have 4x squared, my graph is going to go up. Both are going to rise. If we have a negative coefficient, negative 4x squared, they're both going to go down. Now, odd degree, that exponent would be odd. So x cubed. X cubed, 3 is an odd number. Same thing happens if it's a positive coefficient. If I have a 4x cubed, I'm going to go down on the left, up on the right. If I have a negative out front, it flips up on the left, down on the right. And this is something you kind of have to just commit to memory. Either you remember what it looks like or you don't. That's why we look at the basics first, your quadratic or your cubic. And then you can relate every single odd term and every single even to back to those two. We do write this in a more mathematical way. I will show you how to do that. If you are saying that both ends go up, you are going towards infinity. If you are saying ends go down, you are going towards negative infinity. So in the next example, I will write it both in words and with the mathematical notation. Okay, so we are going to determine the end behavior the maximum number of turns and the maximum number of zeros of each of these functions. So here, this all comes from this leading term. My leading term is odd, and the number in front is positive. So I can tell what my ends are going to be. Odd means they're going to go opposite directions. One up, one down. It's going to go down on the left, up on the right. So to say down on the left and up on the right in math symbols, we would talk about what's happening in the y direction because of which side of x you're on. So when you're on the left side, this is when x is negative, right? So when x is going to be a negative number, a negative infinity, and that arrow means approaching. When x is going to be negative, I'm going to be going down. Y is going to be going down towards negative infinity. On the right side, x is positive. So x is going towards positive infinity, and I'm going to be going up. Y is going towards positive infinity. So these symbols are the mathematical way to write it. I would suggest you start off at least writing it both ways until you get comfortable with the mathematical way to write it. Eventually, that is what I'm going to want all of you to get to. All right, max number of turns. Your number of turns is one less than the degree. So my degree is in x cubed, which means I have a maximum of 2 turns. And my max number of zeros, my zeros is equal to the degree. So since I have an x cubed, I have 3 zeros. Moving on to the next one. I have 2x to the 4th plus 8x cubed plus x squared plus 2. And the only thing I care about, I'm sorry, a negative 2x to the 4th. The only thing I care about is that first term. So end behavior, max number of turns, and max zeros. This is even, an even degreed polynomial because of the x to the 4th, and negative because of the negative 2 in front. So even means they're going to go the same direction. The negative lets me know they're going to go down. So this is going to go down on the left and down on the right. Left and right are your x values, up and down are your y's. So when I'm on the left side, x is negative. So x are negative values. And my down lets me know y is negative. Right is when x is positive infinity, and down again is going towards my negatives. So being able to separate that left is negative, down is negative, right is positive, right, up is positive will help you get through these. Again, my max number of turns is 1 less than the degree. My degree here was an x to the 4th, 1 less is 3. So it has 3 turns. And then my max number of zeros is equal to the degree. So I have x to the 4th means I have 4 zeros. Think about what this could look like. If I had a 4th degree polynomial, both arrows are going down, I can go turn around once, turn around twice, turn around 3 times. I have 1 turn, 2 turns, and 3 turns. And I have 4 zeros. 1, 2, 3, 4. Okay, so now we are going to move forward. We're going to determine these things from a graph. So I'm going to give you a graph. I know that they're both negatives. This is what I get for pulling from the internet. I'm going to give you a graph, and from it I can determine the end behavior, if it's even or odd, if it's a positive or negative number in front, and the number of real zeros. Number of real zeros is how many times you cross the x-axis. So ends, my ends are both going up. So I am up on the left and up on the right. Left is an x value that is negative. So as x is going towards negative infinity, I'm going up. My y value is going towards infinity. On the right, x is positive, and up again means positive for my y. So separating left and right x's and up and down for the y. Since my ends are going in the same direction, I know I must have an even degree polynomial. And since they're pointing up, I know that it is positive in front. It is a positive number in front. And then the number of real zeros is just how many times I cross the x-axis. I cross it 1, 2, 3, 4 times, which means I could potentially have an x to the fourth here. I have 1, 2, 3, 4 zeros, 1, 2, 3 turns. My ends go the same way. It is possibly an x to the fourth. Could be more, but it has to at least be an x to the fourth. All right, now which one has the same end behavior as the one that is shown here? So I'm going to look at these ends. This is not a great picture, but I'm going to look at these ends. I have one here and one here. This is down on the left and up on the right. So since they go opposite directions, I know I have an odd degree polynomial. And since it goes from bottom left to top right, I know the number in front is positive. So I'm looking for a positive number, x to an odd degree. So let's go through our options. First of all, I know my exponent has to be odd. So my exponent is definitely not x and definitely not 6. That leaves me with both of these. Then I look at, is the number in front positive or negative? Negative 10 cannot be negative. It must be this positive 2. So we're just basically matching what's happening on these ends with what's happening on one of the ends of my equations. They're not the same graph by any means. If you put this into your graphing calculator, you will not get this graph. They just behave the same way on the ends. All right, what is true? So here I have a polynomial function. Both of my ends are going up. I have a bunch of terms, all this stuff. So going through these options, which are true? So probably more than one. The first one says the degree is even. Well, if my degree is even, both of my ends go the same direction. In this case, that is true. Is the degree 4? That would mean I can only have 3 terms, 4 zeros. Let's check it. I have, here's 1 term, here's 2, here's 3, here's 4, here's 5. I have 5 terms. So it cannot be a degree of 4. Even though I might only have 4 zeros, I only cross the x-axis 4 times. 1, 2, 3, 4. I turn around too many times for it to be a degree of 4. The leading coefficient is negative. Well, my ends both go up. So my leading coefficient must be positive. So that one is also not true. Is the degree at least 6? Well, I have 5 turns, so I could have a degree of 6. It has to be at least 6 because my turns is 1 less than the degree. So this one is true. And then does it have 4 distinct zeros? We actually already covered that. I have 1, 2, 3, 4 distinct zeros. That one is also true. So these are just different types of problems that I could ask you about. Okay, so these we've actually already done. We did these in the beginning of the year in chapter 1, but these are the other graphing characteristics: relative and extreme, maximum and minimums, and then increasing and decreasing. We already did increasing and decreasing. Remember, an interval is from a starting x value to an ending x value. It looks like a coordinate, but it is an interval. And the difference between a relative and extreme, maximum, minimum, is that the extreme is the absolute top and bottom, whereas a relative is just a high or low that happens in between. So looking at this, we're going to be able to determine all of these things from it. I'm going to be able to tell you what's happening on the ends. I'm going to be able to say the max and min values and where this function is increasing and decreasing. So my ends, first of all, they go in opposite directions. I am down on the left and pointing up on the right. And that's basically just from looking at the arrows here and here. So down on the left, again, left is when x is negative. So when x is negative, my y value is going down. It is negative. When x is on the right, I look at positive x's and it is going up. So y is going up towards a positive infinity. Now my maximum and minimum values. I will not have an extreme max or min because those arrows point up and down forever. So I'm never going to have an absolute high or an absolute low. I will have possible high and low values that are relative. So I'll have relative maximums. Those happen at the tops. So here and here. I have a relative maximum at -3, 2 and 2, 1. And then I have relative minimums at my low values. So down here and down here. -1, -3, and 4, -1. And again, they're relative rather than extreme because the arrows extend below and above those numbers, so there is no absolute top or bottom to that graph. And now when I do increasing and decreasing, that's just where is my graph going up and where is it going down. So this graph starts off here and goes this way. That is going up. So from when x is all the way to the left, on the left, which again is x would be -infinity. So when x is -infinity, until this top point right here, I am going up, I am increasing. That is when x is -3. At that point, I turn around and I start to go down, and we've again already done this. I start to go down from here to here. This is a decreasing interval. So from when x is -3 until when x is -1, I'm going down. My y values are getting smaller. I'm describing the y values in terms of the x's. Turn around again and I start to go up. This is an increasing interval. From when x is -1 until when x is 2. When x is 2, I turn back around, I go back down until when x is 4. So from 2 to 4, all of the y's in between are going down. And then starting at 4 and up forever, I go back up. So that would be 4 to infinity. Again, we've already done increasing and decreasing. We're just re-hitting it. All right, now we're going to sketch some graphs. This is our last thing. We are going to sketch a graph of a third-degree polynomial function, which lets me know that my ends are going opposite directions, one up, one down. I have zeros at -4, 1, and 5. And then I have a maximum at x equals -2 and a minimum at x equals 3. So I don't tell you anything about the y values. I just say that that is a top and a bottom. So I know I have 3 zeros at 1, 2, 3, 4, -4, +1, 1, 2, 3, 4, 5. Those are my zeros. I don't know anything else. I don't know that my ends are going in opposite directions because I have a third degree polynomial. I know I have a maximum at -2, so here is where x is -2. I'm going to have a top of a graph there, so maybe I'll put this little thing up here to let me know maximum. And then 1, 2, 3, when x is 3, I'm going to have a low, a minimum. And then my ends need to go in opposite ways. So it seems like it would be best to connect this graph this way. So why not just make my end go down there? And then here is my maximum value. I'm going to go back, hit this 0, go down to the minimum value and back up through my 0, and then continue on. My ends go in opposite directions. Check. I have a maximum here, a minimum down here, and then my zeros cross through my x-axis at the correct places. Perfect third degree polynomial. Let's do it again. I have a possible 5th degree polynomial. So again, my ends are going to go opposite ways. Spelled degree wrong. A negative coefficient, which means I'm going to go up on the right and down on the left. And then I have zeros at -3, -1, 0, 2, and 5. So this one gives me, honestly, a little bit more specifics. I know I'm going to cross through 0 at -1, 2, 3, -1, 0, 1, 2, and then 3, 4, 5. I know I am going up on the right and down on the left because of my end behavior. And now I just need to connect my dots. Since I have a 5th degree, I cannot turn more than 4 times. So I need to only turn around 4 times. So if I go through here and turn around, there's 1 turn. Now to connect these, here's another turn. Now connect my next 2 0, here's a 3rd. And here was my 4th. And then I just go straight down. So it's actually more simple than you think. I give you enough information and then you just connect your dots. And the last question, the graph of which polynomial function is shown. So I'm going to figure out what I need to know here. Looking at my ends, one is down, one is up. That means I have an odd degree polynomial. Since I am down on the left and up on the right, I have a positive number in front. So right away I can go through these and eliminate any negative numbers. So since I'm looking at, and these are in factored form, so that means I'm probably going to look at zeros. I'm going to be able to eliminate the negative ones. So the first one has a negative value and the last one has a negative value. And I was talking about, when I say negative, I'm talking about this number in front here, this sign. So those two are out. Now I'm just looking at what my zeros are. So I am looking at where I cross the x-axis. I cross the x-axis there. That is x equals -1. And again, at x equals 1. And for a third time at x equals 4. So I need to look at the functions that I have left and figure out what the zeros are. So if I set each one equal to 0, I can determine what those zeros are. When this factor is 0, x minus 1 equals 0, I have a 0 of 1. When x plus 1 is equal to 0, I get a 0 of -1. And when my last factor, x plus 4, is equal to 0, I get a 0 of -4. Well, I need a 0 of +4, so it can't be that one. I'm going to double check my answer, which right now is C, and make sure that that's correct. My function is x minus 1, x plus 1, and x minus 4. So when x is x minus 1, my 0 would be 1. When my factor is x plus 1, my 0 would be -1. You just move the number over to the other side. When x minus 4 is my factor, my 0 is 4. So there are all three of my zeros, -1, 1, and 4. C is my correct answer. All right, that's it.